Hello, hello. How's everyone doing? How were your morning classes? Let's take a few minutes, wait for people to come in. This is your attendance for today. Make sure you sign in. Yep, attendance is right there. Hello, hello. Let's take a few minutes. All right, so today's national holiday is Happy Earth Day. Have you guys heard about Earth Day? I know earlier today I had students talking about their clubs. That was really cool. Hi, Chelsea. All right, for those of us who just got here, this is attendance for today. Yesterday, I watched Godzilla with my family for the first time, the 2014 and 2019 edition, and I found a very interesting quote from the Godzilla King of Monsters movie. I put it here. You guys can read. It was really interesting. I've also included some fun facts about Earth Day. I didn't realize that it was a byproduct of the oil spill in California. That was kind of cool. The question for today is, what is some eco-friendly thing that you've done and can do on a regular basis? Feel free to put it in the chat. We'd love to see how you guys do eco-friendly stuff. It'd be really cool. For me and my family, what we've done a lot is to use eco bags when grocery shopping. It's been pretty good. For those of us who just hop on, this is attendance. Also try to stay for the entire session, because when I was grading your assignments, I think some students or quite a few of us got confused on stuff that we went through in class. So try to not log off too early and stay for the entire thing. Okay, cool. Yeah, so if you want to share a little bit about your eco-friendly habits, feel free to put in the chat. We're gonna take about a minute or two to get more students coming because there should be more of us. Let's see who we should invite. Let's see. Hmm. Yeah, reusable bags for groceries for sure. Yeah, we have people from morning class talking about metal straws. I don't know if you guys are big into like boba or milk tea. Those are really good alternatives as well. All right. Okay. Let's take about 30 more seconds before we move on to announcements. Ah. Mm-mm-mm. All right. Okay. I think we are ready to move on to announcements. So for today's announcements, we are on our last lesson of our mini unit of polynomials. So that's exciting. Yeah. All right. Office hours reminder. If you have any missing assignments, I will be calling you into my Monday appointments from 10:30 to 12, obviously not during your class time. But because I'm not staying with you guys till the end of this quarter, so I want to get you guys to finish as much as possible. I had a lot of people coming to me at the end of the quarter, and that was a lot of hassle because I won't be here. I won't be able to do that. And as always, Tuesdays, Thursdays, 10:30 to 12 p.m. And it's been good. I think there are more students coming into office hours and trying to get their missing assignments complete. So that's awesome. All right, we're going to start by going through some of the common mistakes that we had with our last assignment. Okay, so Can someone tell me what's wrong with this response? So just so you know, the single root and double roots, the responses are actually correct. It's the graphs. Can someone tell me what's incorrect about the graph? It could just be Desmos because it's hard to sketch on it, but a few of us had this mistake, so I want to make sure that we have it discussed. For those of us who just got in, this is attendance. If you want to say something, come off mute. That'd be perfect. If not, you can private message me. That's okay too. Or you can just leave in the group chat. Yeah. So with this one, you see how this person recognized that there's a double root at -1, but the way this person drew it, the line went directly through the point. The whole point of double root, it's supposed to bounce at the point. So we should have something that looks like that. And then like that. Yeah. So that's how you do this question. You don't want to bounce at points. That's not our solution. Cool. All right. Thank you for the help. That's awesome. And we can move on to the next one. The next one is this. So like the other one, we got the correct solutions, but our sketch was not correct when it comes to the bounce, right? Because it's a double root, it's supposed to be a parabola. So what we should have instead is at x is 3 and x is -1, we're supposed to bounce up. So we have bounce up here once, and then we want to bounce here as well. So it should look like a W, right? Remember, it's a quartic function, meaning it's x to the 4th power. You have 2 plus 2 exponents, which is 4, and that's how you do that. All right, cool. Another question. Oh, not a question. Here we have some shout outs for some great work that I've seen. So overall, awesome job with the assignment. I love how you guys make notes as you guys work through the problem. So here are some examples from Nayeli, from Marcy, from Jessica, from from Daryl, and from Leslie. There are a lot more, but I just couldn't fit them in one page. So I selected the ones I first see based on my grading. Yeah, great job. Good job to all of you guys. Okay. What's my next slide? Oh, sorry. Let me stop, annotate. Cool. And yeah, that's it for the announcement portion. I'm going to launch the poll, and please let me know when you're ready for class. Let me see. It's the timing poll. Here we go. If you need a few minutes or you're ready to go, you have your pen and your paper out, that'd be great. Okay. Seems like we have a few people who need a few more minutes. Cool. All right. Let's see. I'm going to start sharing my screen. We're on assignment 37. Let me grab the assignment, the notes, and the assignment. Uh-oh. BRB. And go back to Zoom accidentally here. So this is the link for notes 37 and assignment 37, just in case you need to download it. And let me grab my screen so I can share it with you guys. All right. Okay. We're going to take another 30 seconds before we hop on. As always, if you have questions, feel free to ask immediately, come off mute, or if you want to, private message me or leave in the group chat, that works too. All right. Okay. I think we are good to go. So for today's class, we're going to be talking about key features of polynomials. So the two new things that we're learning today are turning points and end behavior. So those are the two new things that we're learning today. We've already done zeros and one intercept in the past, so it should be pretty straightforward. So can we start off by having someone tell me what the zeros are of this function, y equals x plus 2 times x plus 1 times x minus 2? Feel free to comment in the chat or come off mute. Either way works. Thank you, Gracia. Exactly. Our zeros are at -2, at -1, and 2. Can you come off mute and tell us how we got it? Do you mind coming off mute? If not, that's completely fine. Yeah, definitely. Type instead. Type works too. Thank you. Thank you. Appreciate. Exactly. So Gracia's method is to flip the sign. So that's one of the methods, right? So what we could do is we could look at our equation, right? Our equation is x plus 2, x plus 1, and x minus 2. All you do is you flip the sign. If it's positive, change it to negative. If it's negative, change it to positive. That's awesome. Great job. Other method that you can use is to look at the intersection point of our function y. So the red curve is the y function with the highlighted portion, which is on the x-axis, right? Okay, so here you can also see it's a -2, -1, and 2. Perfect. All right, can someone remind me how I can get the y-intercept? Yeah, exactly. So for y-intercept is looking at where your function, your equation, your y touches the y-axis. This is the y-axis. This is the y-axis. So here we see that at -4, our function touches the y-axis, and that's how we know that it's the y-intercept. The other way to think about it is where your graph is when your x is 0, right? X is 0. All right, so here we're learning the new theme. It's called turning points, and we're going to introduce two subcategories within turning points. We'll be talking about local minimums and local maximums. So local minimums and local maximums essentially just, it talks about like, it's like if you have a region, if you space out like a region around the parabola, the curve, and you want to find the highest point and the lowest point within that region, right? That's why it's called local. So what I mean is if, say, let me choose a color. Let's say we're using blue, right? You see, whenever you have a parabola, these are parabolas, right? If you have a parabola, you want to circle around it. You want to box it out. You want to box out the area immediately before after your parabolas. So we have two parabolas, so we're going to zone out two of them. You want to zone out both of them. So for local maximum, all you're doing is to find the highest point, right? So in this case, if we're looking at, say, this is 1 and this is 2, at number 1, we see that there is a highest point, and the highest point is at this point, right? This point is the highest compared to all these other points, right? That's why we know this is a local maximum. Another way to think about it is, say this is a hill, right? If you want to find the maximum, you have to be on top of the hill, right? Oh, we're moving around. So we're standing on top of the hill. So hill equals maximum, okay? The other example, looking at number 2 that we zoned out, is what we call a local minimum, right? This is the minimum because we are at the lowest point, right? This point is the lowest point compared to all those other points, right, around it. Can you guys see the little green dots I'm doing? Great. So another way to think about local minimum is think about a valley, right? Say I'm at the lowest point of the valley. So when you have a valley, you know it's a minimum, all right? So this is an example of local minimum. And after you spotted these locals, these turning points, let's look at our number 1. Let's look at our local maximum. All you have to do is to figure out what the x and the y is at this point. So here I know that, hey, my x is in between -1 and -2, so it will be -1.5. And for my y, it's exactly at 1, so it's at 1. So my local maximum in this graph is at -5. I have a -1.5, sorry, -1.5 at and 1. That's my local maximum. And my local minimum, right, if I jot down this side, just bring it down directly, we have 1 for my x, and we have -6 for my y. So it's a 1 and -6. So I have 1, -6 for local minimum. The last concept to think about is end behavior. And end behavior, essentially, it defines the graph as x gets either really, really, really big, or when x gets really, really, really small. Really small. Can someone in the chat tell me, if I want a really big x value, do I go onto the right side of my graph or do I go to the left side of my graph? So on this graph, the biggest x value I have is 3. Exactly. Thank you. Thank you, Gracia. So if you want a really big, like, x value, like a million, 10 million, billion, you want to go very far to the right. So let me write it down. So when x is approaching infinity, we're going, means x goes far right. Okay, so what we want to do is we want to see where the right side of our y, the end of the right side of our y, look like. If it's going upward, we will say f of x is approaching infinity. And this is the notation, right? So what I want to do, if I'm looking at x approaching infinity, we will be looking at the end of function on of the right side. Okay, that's why, because in this example, the end of the right function is going upward, I know that, hey, it is an infinity. It's approaching infinity. Okay. On the other hand, if I have x approaching negative infinity, meaning it's like a very, very small number, we will be going to the left side. Left side when negative infinity. So x goes far, this is also an A, far left, right? So when we're looking for x in the far left, we will be looking at y, like how the end of the y look like on the left. So when x approaches negative infinity, we will be looking at the end of function of the left side, right? This is the left side, right? So in this case, our y, the end of the left side of function is going down, right? When it goes down, it means that, hey, I have a function that is approaching negative infinity, right? Similar to the x and y's, when y goes down, it's a negative value, right? And it keeps on getting bigger and bigger. That's why it's approaching negative infinity. Okay, so this is how we do the first problem. I'm going to launch a poll and you're going to tell me which part you're still confused about. If you're still confused as to how we got the zeros, you're going to choose option A. If you're confused as to how we got the y-intercept, you're going to choose option B. If you're confused as to how we found the local maximum, you're going to choose C. You're confused about local minimum, you're going to choose D. You're confused about end behavior in general, you're going to choose E. And you're going to choose F if what we just went through makes sense to you. All right, so let me launch a poll real quick. Remember your options, okay? So your option A is when you don't get how we got the zeros. If you're choosing B, it means you don't know. Okay, so the person who chose IDK, please private message me and tell me which part I lost you, so I can better explain it in the next example. Because if you just say I don't know, it's really hard for me to help you figure out. So far, I only have 2 responses, and the 2 responses are IDK. So please be more specific so I can help you with it. Thank you so much. Appreciate it. So we have, cool. So we have confusion with C, local maximum, and then 1 in general and behavior. Okay, hopefully if we look at the next example, we're gonna have those questions and those doubts answered, but we will see. And let me know if you have questions at any point, just let me know, right? I can answer it more efficiently that way too. All right, cool. Let's look at our second example. Second example asks us to match the letters with the correct terms. Okay, so zeros. Out of A, B, C, D, E, and F, what are the zeros? Feel free to private message me, right? As a hint, right, I'm gonna draw out this line. Please try it out so I know how I can help you guys. Yeah, your zeros will be at A and D. It's going to be at A and D because A and D are the 2 points of our y-axis, right? Remember, not y-axis, y function. This is our function, right? The red line that touches our x-axis, right? The highlighted part is the x-axis. Great job. Great job, guys. Okay, how about the y-intercept? How do I tell when I have my y-intercept? Private message me the response, please. We much appreciate it. Yeah. So y-intercept is the point that of our function that touches the y-axis, right? So in this case, our function, point C touches the y-axis, right? This is the y-axis. So this is point C. All right, I'm gonna launch a poll for this one. I think this will be a very interesting one to look at. Okay. So for maximums, right? Do you think we have one maximum or two maximums? You can choose multiple in this one. So we have already chosen A, C, and D. So it means that maximums could be either B, E, or F, or B, E, and F, right? You can have more than one. Yeah, that is awesome. That's the correct response. Yes. The answer is E. For the person who chose E, do you want to come off mute and tell us how you got E? Or the people who got, oh, we have multiple people who got E, which is great. Do you want to come off mute to tell us how you got E? Or you want to type it out or anything? Yes, no, maybe. Feel free to say no, but you just have to let me know, or else I'll wait for a little bit. Okay. Oh, you can explain it in your own words. Sure. All right. How about I try to phrase it and then you see if that's similar to your explanation. All right. So what you want to do, right? Remember, for the local turning points, what we want to do is we want to kind of box out any curves, right? Any parabolas. Like this is a downward parabola. This is an upward parabola, right? There are different types of parabolas, but essentially you want to box out the parabola. And you want to get to the parabola as close as it is to the point, right? So here we have one parabola. That is one parabola. We're going to call it number 1. And we have another parabola here. 2. And then our last one will be here, right? And I know that they are parabolas because look, that looks like that, right? For F, F looks like this a little bit. And then for B, B looks very distinct. B, right? They are all parabolas. So let's look at number 2, which is E, right? I know this is a maximum because look at all those points. I'm going to choose a color that's bright enough. Okay, I'm going to choose white. So look at all those points that's building onto E. They are all shorter than it. It's not as high. That's why I know that the points around E are smaller, are lower than E. So they must be like kind of building to that point. So that's why I know that, hey, at E, I'm standing on top of the hill, right? That's why I know, okay, at E is when I am at my local maximum because I'm also standing on top of my hill. There's no other point around me that's taller than me. Okay, so that's why E is the local maximum. I hope the analogy makes more sense. All right, so let's look at minimums, right? So I've boxed out 1 and 3. Let's look at why they are minimums, okay? So at number 1, which is F, you see I'm at here, right? This is the lowest point around all those points, right? And when you're at the lowest point around different points, that's when you know that you are in the minimum position, right? Remember the valley example? This is the valley and you're here, you're at the lowest point. And that's why I know, hey, I'm at a minimum. So F is one of the minimums. And let's look at why B. So B similarly, B is even more distinctive, right? All those points around it are taller and higher than B. but B is standing on its own, very, very lonely at the bottom of the valley. And that's why we know that because we have a parabola with a point at the lowest mark, this is considered a local minimum as well. So B, in this case, is also another minimum. All right, time to try out end behavior. I know it can get a little bit tricky, so I'm going to give you guys a reminder. So when x approaches infinity, it means that we're going far right. Right, we're going to go far right to get a very massive positive number. When x is approaching negative infinity, we're going far left to get a massive or massively small number, right? And the y function that we're looking at, when x is approaching infinity, we're looking at the end of the right side, end of the right side of function, right? And then on the other hand, when x is approaching negative infinity, we're looking at our y function at the end of the left side of function. Okay, so with these reminders, do you guys think you can try to tell me whether our f of x is approaching positive or negative when x is approaching infinity? Right, when x is approaching infinity, we're going far right. And what I mean by we're looking at y, the end of the right side of the function, this is the end, right? And this is on the right side. So this is the end of the right side of the function, okay? So if this is going upward, it will be infinity. But if it's going downward, it will be negative infinity. So can someone leave a message in the chat and tell me whether I will be at negative or positive infinity as x approaches infinity? Yes, that's perfect. So we're reaching positive, right? So it's because we're going upward, right? We're going upward. Going upward, I know that I will be reaching positive infinity. Great job. All right, the last bit is to look at what would happen when x approaches negative infinity, right? At x approaching negative infinity, what happens to the end of our y function on the left side, right? When x approaches negative infinity, meaning we're going far left. Am I going upward? Upward for infinity, or am I going downward for negative infinity at this point? Yeah, we are moving upward. Because we're moving upward, I know that as x approaches negative infinity, going really, really far left, my y is still going upward. So you see how in the previous example, we had a positive and a negative infinity? But for this one, we have two positive infinities. You just have to know that it doesn't really matter. You don't have to have alternating sign for our y. All we have to do is we have to make sure we have a positive infinity for the x and a negative infinity for the y, for the left side, right? You want to go to the right side and the left side for the x. Y is just dependent on like whether it's moving upward or moving downward, all right? Okay, I'm gonna launch the poll again. All right, don't pick anything yet, all right? So if you're still confused with, sorry, excuse me. If you're still confused with how we found the zeros, give the A, press A in the poll. If you're confused with y-intercept, press B. If you're still confused about the maximum, press C. D for minimum, and E for the end behavior, and F if it is starting to make more sense. All right, let me get the poll started. Cool. Oh, this is great. I think we're moving more towards understanding completely. Hopefully, the last question can answer more of our doubts and confusions. But we are moving at a very good direction, in a very good direction. All right, sounds good. Okay, cool. We have our last example. All right, our last example. Let me try to erase the other parts so we don't get distracted. Cool. So this is what we have. We have y equals 0.4 times x plus 3 times x minus 2 times x minus 3. All right. Can someone tell me where my function is, my zeros are? My zeros, right? Touching my x-axis. Thank you. Yeah, exactly. I know that my zeros are at -3, at 2, and 3 because they are touching my x-axis. Another way to check is to flip the sign. Like Gracia said, we want to flip the sign and we can get the answer. All right. But usually when you have the graph, it's a lot easier. And with today's assignment, you'll see that I think there are some questions that you put into Desmos, and Desmos automatically gives you the zeros. Super convenient. All right. Okay. Next question to ask is the y-intercept. All right, the y-intercept. Oh, somebody's already ahead of me. Yeah, y-intercept is just wherever our function touches the y. Yeah. Our y-intercept is at 0, 7. Perfect. Okay. Next question is maximum or maximums, right? So before we determine maximums and minimums, we just want to box out any of the parabola that we see. So we see that there's one parabola here. You want to you don't need like a big box. You want to really zoom in onto the box, right? So that's one. Oh, this is a tricky one. All right. I just don't want to cover the points. So I'm just going to make it slightly bigger. Okay. No, kind of look like a cat. All right. JK. Sorry. Okay. So that's what we have. We have two boxes boxed out, right? And we don't know which one is the maximum or minimum yet. It depends on how we stand, right? Okay, so let's say I want to check out this. All right, this orange one right here, this orange point, let's call it point 1. All those points around it are lower than it, right? Because it's lower than our point, I know that I am on the top of the hill. So I am at the highest point. So I know it's a local maximum, right? Because I'm on top of the hill. So I know that, hey, this is my local maximum. All I have to do is to figure out my x, right? You want to get your x before your y. So it's at -1. And my y is just here. Between 10 and 9 looks like about halfway through. So I'll say 9.5. So I found my maximum at -1 and 9.5. -1 and 9.5. All right, I think that's the only maximum I have because this other one I have, I'm at a very low point, right? I'm at the low point. I'm the lowest point of all the points around me. I'm here. I'm at the end of the valley. Valley equals minimum, right? So I know that I'm at my local minimum. All right, let me erase the sketches so we don't get confused, right? So I know this is my local minimum. So all I have to do is to find my x and my y, right? So my x is right here. I'm in between 2 and a 3, so that leaves me with 2.5-ish. And for my y, I'm just dot it to the side. Looks like I'm at halfway between 0 and -1, which is -0.5. So my local minimum is at 2.5 and -0.5. All right, last bit of it. In my last bit, I'm gonna have end behavior, right? So I have when x approaches to infinity, which means that we're going very far to the right. We wanna look at the right end of our y function. Because we're moving upward, I know that this is, what do I know about this one? If the right end of my y function is going upward, is it positive or negative infinity for our y? Is our y approaching positive infinity or negative infinity? Oh, also, you don't usually say positive infinity, you just say infinity. Yeah, awesome, great. So it will be y approaching infinity, okay? That's how we know. Thank you, Risha. I'll make sure that Ms. Mac knows that you will get merit points. Thank you for your help. All right, the last bit is to determine what happens to our y function when x approaches negative infinity, meaning we're going very far to the left. So what I want to do when we're looking for x approaching negative infinity, I want to look at the end of my function on the left side, right? So will this be infinity or would this be negative infinity because of my direction? Am I going up or am I going down? Yeah, because we are going down, I know that, hey, my y is going down when x is going very far to the left. So this must mean that my y function is approaching negative infinity. All right, and that's how we get our zeros, y-intercept, our maximums, and our minimums. Okay, I'm gonna do one poll and hopefully you guys are getting a little bit more of this. If you guys really are still confused, what could happen is you can schedule an office hours meeting with me. Tomorrow I'm hosting office hours at 2:15. So if you still want to get your questions clarified, you can always hop on. But if you're still confused with, let's say, A for zeros, B for intercepts, y-intercepts, C for maximum, D for minimum, E for end behavior, F if you understand it. Okay, let's take like a minute to do. Awesome, well done. All right, that's great. If you still feel confused, that's completely fine. I know that we've learned about end behaviors and turning points. Those are the two new things that we learned today. They can be kind of tricky. So if you have questions, feel free to ask me. If you can't make it to my normal office hours, I can have office hours by appointment too. All right, do you guys want to kind of look at the assignment? So before I let you guys go, just like a quick run through of the assignment. So just slap your notes here. Notes that you did today will be here. And for part 1, depending on your category, if you're on track, you do 4. If you're honors, you do 6, right? So you can pick those questions. So from 1 through 3, those diagrams are provided for you. For 4, 5, and 6, you have to copy and paste the equation into Desmos, and then remember to take a screenshot of those diagrams and you answer the same questions. And it should be pretty straightforward. I'm pretty sure there is extra credit. So if you want to get some extra credit, you can play a Gimkit game. And yeah, if you have any questions or confusions, like please let me know. I'll try to answer the best of my ability. If you guys don't have any other specific questions, you guys can log off. Thank you for an amazing session. Chelsea, did the lesson make sense today? Nope. Guess we logged off. Great.